Good morning, and I hope you're enjoying the beginning of your day off if you're actually awake yet. I know I'm enjoying mine. I wanted to take a little bit of time to talk through this last day of our unit on proportional reasoning. On Monday, we will have some time to practice, and then on Tuesday, you will have a concept test on this. And I hope that you can continue to use what we learned about scaling here, and that this work with proportional reasoning will continue to apply as we go through the year. So today I really wanted to put a lot of things together. And in particular, now that we've focused very heavily on tables, somewhat less heavily on equations and graphs, I wanted us to take some time to connect what's going on in the tables that many of you are quite comfortable with and what's going on in the graphs and the equations. Starting with our practice check, I happily stole this question from Nikayla. She wrote the situation out. And we've got this. Mike can do one homework assignment in 60 minutes. Lucas can do 3 homework assignments in 90 minutes. Assume that these are both proportional relationships. Now that's an important assumption to make, because if you're not assuming that, then in 2 hours they could both do something completely different, and you really can't set up a systematic graph or table. So we're assuming these are proportional. You want to graph them both and label whose line is whose. And I'm going to start just by labeling my axes. I know that I'm looking at time in minutes, and you could choose to do it in half hours or something like that, but I'm choosing minutes. So I'm going to think about 30-minute chunks. And for homework assignments, it seems like it would be reasonable to think about one homework assignment at a time. So since we had 1 and 2 given, I figure going up to 4 or 5 homework assignments seems reasonable. And I can just equally space those so that I have 1 through 5 homework assignments. Of course, down at the bottom left, that would be 0 homework assignments. That's the origin. And then, like I said, I'm going to do it in increments of 30 minutes, but so that you can get down to the 10-minute increments if you go to those third pieces along the way. So now I'm going to graph Mike's setup, and then I'm going to graph Lucas's setup, and I'm going to keep them in different colors so that it's clear which is which. Mike is going to do 1 homework assignment in 60 minutes. Along the y-axis we see he's completed 1, along the x-axis we see 60 minutes have passed. So if I graph that, oops, I'm sorry. Gotta love your technology. Okay, so if I graph that, I can see that it would continue up. For example, if I went up to 120 minutes, I now would complete 2 homework assignments, and that scales. We've taken 60, that's doubling the time, so we're going to double the number of assignments he can complete. The reason I went back to 0, 0 is because any proportional relationship has to start with 0, 0, because if he has no time, he's not going to complete any homework assignments. Now, Lucas can complete 3 homework assignments in 90. Looking at the y-axis, we see it's at 3 homework assignments. Looking at the x-axis, we see it's at 90 minutes. If I also plot that so it goes back to the 0, 0, no time, he's not going to complete any homework assignments. We see that if we go to 2 homework assignments, that would take him 60 minutes. 1 homework assignment would take him 30 minutes. And if we continued up, we could see that 4 homework assignments would take him 120 minutes. So looking at this, there are a couple ways to think about who's going to complete the homework more quickly. I have 2 specific things that I note here. Say that Lucas can complete assignments more quickly because it only takes him 30 minutes to complete 1 assignment. That's where I said continue back along the pink line. You'll see that he can complete that 1 and it takes him 30 minutes. Where for Mike, it takes 60 minutes to complete 1 homework assignment. Additionally, you can see that his line is steeper, and we talked about that on Tuesday and a little bit more yesterday discussing the homework, that when you see that that line is steeper, that's a clue that the unit rate is higher because you're moving up more quickly. Now, like I said, we're going to combine tables, graphs, and equations. I'm going to pick just one of these to talk about, A, B, and C. Students in some classes every student at the table had a different point and they were then discussing them. In other classes, every table had a different point and we were kind of discussing whole group what was different between them. But for all of them, the mechanics end up being the same because we have a proportional relationship, so it's going to go through the point 0, 0, and that's going to affect how you can calculate your constant of proportionality and what your equation is going to end up looking like. So I'm going to look at A, which is the point 10, 4. Label 10, 4. And my direction 2 is to line my point up with the origin and draw that proportional line. Okay? So we've got our line. I didn't continue it to the edge of the graph, my bad, but it's already pretty close. And I notice, all right, if I have 10, 4, moving back, if I cut that in half, along the x I would have 5, along the y I would have 2, so that would just be cutting it in half, and then it continues down to 0, 0. On the table then, I want to fill in some of these points. Oh, excuse me, so that would be 5, 2, like I said. So on the table, we know that at 0, we're going to be at 0 along the y. And you can't divide by 0 in any meaningful way right now. And so we would say that y divided by x, so the ratio of y to x, is actually undefined because there's no number that you can multiply 0 by to get, well, specifically, there's every number you could multiply 0 by to get 0. So there's no specific number that you can multiply 0 by to get 0. I'm also then going to put in my original points. If I had x10, y is going to be 4, and that's my point that I had been given. If x is 5, y is going to be 2, and that's when we cut it in half. And now I need to get back to when x is 1, because that's my unit rate. That's how I can talk about my constant of proportionality. And I'm going to use the 5, 2, but you could also use the 10, 4. If I'm going from 5 to 1, I would divide by 5. So to keep that proportional along the y, I'm also going to do divide by 5. So I would have 2/5, or 2 divided by 5. That's the same as 4/10. So now all my ratios, they are defined for all the other numbers. If I have the ratio of y to x, that would be 2/5 or 0.4 again, 4/10. 4 to 10, that would be 4/10 or 0.4, 4/10. And if it's 0.4 to 1, 0.4 to 1 is just going to be 0.4 or 4/10. So we have a constant ratio, we have a constant multiplier. We don't worry about that 0, 0 because it's always going to be undefined. So in order to find your unit rate, you need to look past 0, 0 at what other points are there, because 0, 0 is on every single proportional graph. So now I know that I can multiply by 0.4 or 4/10 across the table. That means that that's my constant of proportionality here, going from x to y. If I want to write that as an equation, if I take x times 0.4, I will get y. So y is going to equal 0.4, 4/10 times x. So that's a way to write that equation. And for the other 2 points, 4, 5, and 5, 8, points B and C, I would end up with the same mechanics. Now the constant of proportionality for whatever those points would be replacing 0.4 in my equation. So I want to look at some connections between these 3 representations, or among these 3 representations. When you have a graph of a proportional relationship, what's helpful about that is if you get to the point x is 1, y is going to be your constant of proportionality. And you now know your unit rate for the situation. If you're looking at an equation, it's that number that you're multiplying by the variable. So if you have a graph and you can find constant of proportionality at the point 1 blank, then you could use that constant of proportionality in your equation, multiply it by the x variable to get your y. And if you have a table, you could take that point, that would be at x equals 1 at that row, which you know we can also scale down, and it's also the multiplier across the table. A benefit of graphs and equations is that both of them can give you every single point. When you have that graph that is a solid line, if it's appropriate for it to be a solid line, that's telling you every point along that line is going to be true of this proportional scenario. With an equation, you can find every single number now because you can multiply and divide any of your x's and y's in order to get the other variable. With the table, it would be tedious to do that because it would take forever and in fact be impossible, because there are an infinite number of points that are possible in a proportional relationship. A benefit of tables and equations are that they give you very clear numbers. With the graph, you have to do some interpretation of the graph, where with the equation and the table, you see right away what those numbers are going to be. And a benefit of tables and graphs are that they are a clear visual representation. For a lot of people, tables are great for organization, and graphs let you see some patterns and trends more quickly than you might in an equation. But at the end of the day, all of them show you the constant of proportionality, which means they show you how those quantities in the relationship are related to each other. And that's the power of all of these representations. If you can move flexibly between them, you'll be able to see different things, but with any of them, you can do really strong work. So you should kind of find what are you most comfortable with and how can you relate it then to the other representations. So to sum up, in a graph, you see the point 1 blank at that point where x is 1, and the blank would be your constant of proportionality. In a table, it's at the x equals 1 row. If you can get down to x equals 1, it will be the y, and it's the multiplier across that table, that constant multiplier. And in an equation, again, it's that constant multiplier that you are going to use to get from your x variable to your y variable, or your y value. So several weeks in, we have 3 representations that you should be starting to get more comfortable with moving between and across. I know a lot of people continue to feel like a table is the simplest way for them to organize information. So I counsel you, whenever you're given a scenario or you're approaching a question that looks like it's proportional, or you're trying to see if it's proportional, make yourself a table even if there isn't one, and then you can work from there and see if another representation would also be appropriate. Have an excellent long weekend. I will see you on Monday.